Okay, welcome to your first Unit 6 note video of the try. So we're going to start by just introducing exponential functions. And exponential functions are something that you guys have seen before. It's not new. Okay, so what we're going to do is, first of all, we're going to talk about what an exponential function actually is. So we're going to start by using an example from an artist. Okay, so you look at that picture on there, and we're talking about how he's going to make that picture. So what he does is he's going to carve a large pair of pliers in the tree, and then from each of those pliers that he makes, he's going to split them in half. So each is going to become two, and then each of those two will become two more. So it's just going to keep expanding, and that's how you get the design that you see on the board. And this can all be represented mathematically. You could take a look at this chart right here, and that represents how it can be seen mathematically. So you have that chart written on your sheet. So we start off with one. We start off with one plier. Okay, so that means we've done no cutting. So we have 2 to the 0 power. Well, then we're going to start with our first cutting. We're going to split it into 2. So we're going to split it once, so we have 2 to the first power, and now we have 2 pliers. We're going to do it again, so we're going to take each of those 2, and we're going to split them each twice. So now we have 2 to the second power, which gives us 4 pliers, and that keeps going all the way down. If we cut each of those, and eventually if we're doing it 8 times, we're going to end up with 256 different pliers. So this may not make a whole lot of sense right now, but we'll get there. Okay, so we're going to work towards understanding, what is happening when we do all this. And you see exponential equations all the time in real life. So before we can really look at, where you're seeing them, we're going to take a look at how to actually do it. So let's just talk about exponential functions to start off with. So my recommendation for you right now is to just pause the video, write this stuff down, and then you can listen to me talk as I talk through it. To start off with, an exponential function is typically in the form y equals a to the x. Okay, that's the most general form. Okay, so when this is happening, our a has to be greater than 0. Okay, so we don't want to deal with negative numbers when we're doing this. So we want a positive number, and we also don't want a to be 1. Well, here's why we don't want to be a to be 1. If you look at that previous chart, we were multiplying 2 times 2 times 2 times 2. We were multiplying it a bunch of times. Okay, if I multiply 1 times 1 times 1 times 1 a bunch of times, I'm always going to get 1. That's not exciting to me. So that's why we use 2's. Next, when we're talking about any other function, um, we've been, you could always make a table. When we did quadratics, when you graph lines, you could always graph a table to get your graph. You can do the same with exponential functions, and that's actually what we're going to start with today. So let's take a look at y equals 4 to the x. So what I want to do to start off with is I just want to make a chart. So I have y, my y side, and my x side. And you know what, let's write it the other way so that we get ordered pairs when we write it out. So we have x and we have y. So I'm just going to find a couple values for x. So let's just plug it in. Well, I have y equals 4 to the 0. Well, when you plug in 0 for x, then you remember from unit 3 that anything to the 0 power is automatically going to be 1. So there's our first one. Then we can plug in for x to get our next one. 4 to the first power is 4. Next, 4 to the second power is 16. And last but not least, 4 to the third power gives us 65. So let's plug in what we can here to at least get a general shape. So it's going to be kind of like a ski slope going up. That's what it's kind of going to look like. So our y-intercept is at 0, 1. We're crossing the y-axis at 1. When x is 1, y is 4, so we're going over 1, up 4. When x is 2, y is 16, so we're going all the way up to 16. So all of a sudden, we just shot up on our graph. Okay? So we can take this and we can actually connect it. I can't quite get to 3 on my graph, so it's going to shoot up off of my graph. So that's a really steep ski slope. Okay, but that's kind of what exponential functions are going to look like. This one is called growth because it's growing upward. You can also take a look at this chart right here. So what I'm going to do is I'm going to get you started. And then I want you to plot these points yourself and get the general shape. So we want to look when x is 0, 1, 2, and 3. Okay, so when x is 0, you're going to plug that in, and you're going to get 3 to the 0, which is 1. When x is 1, you're going to get 3 to the 1, which is 3. When x is 2, you're going to get 3 squared, which is 9. So all I'm doing is plugging in for x right now. And then 3 to the 3 is 27. So what I want you to do is on your notes, just pause the video and I want you to plug these points. You should get a ski jump just like I did in the first one, but yours is going to be a little less steep, okay, because we're using a smaller number than 4. So pause the video and then continue when you're done. So let's take a look at decay. What decay means is that that means we're going to actually be going down, and these are going to be changed to positive. Okay, so let's just take a look at this. So again, let's make our chart. That makes our life easier. So we have 0, and what actually helps us when we have fractions is something interesting happens. So I'm actually going to take a look at -1 as well. So instead of doing 0, 1, 2, 3, I'm going to take a look at -1. And I have a lot of students ask me, how do you pick these numbers, okay? And it is really up to you, but in general, numbers closest to x is equal to 0 are your best options, okay? They will give you the most convenient answers. So I have y is equal to 1/2 to the -1 power. So again, if you're thinking back to that unit 3 when we talked about rules of exponents, if you have anything to the negative power, you need to flip where it's located. So this is actually 2. Okay, this is 2. Okay, we can change this up and now we'll do y to the 0 power. When we do that, we'll automatically get 1. Change it up again, and when we have 1/2 to the 1 power, we're just going to get 1/2. And then lastly, when we have 1/2 to the 2 power, remember when you're taking a power of a power, you need to distribute that 2 into both things. So then you end up getting 1/2 squared, which is 1/4. So let's go ahead and plot these points. So we're doing -1, and then we're going up 2. We're going to 1 and up 1/2. Or sorry, at 0 we're at 1, and then 1 we're at 1/2. And then 2 we're getting even smaller because we're down to 4. So we're really going to touch that x-axis. That's the thing with these decay equations. And same thing for the growth equations, but on the other side of the y-axis. We're going to touch the axis, but for right now, we're never going to cross the axis. Okay? So let's get you started on this next one. Oh, sorry, before we do that, let's take a look at this estimating. So I want to see what 1/2 to the 2.5 is based on my graph. So I'm going to estimate. My lines didn't draw real well, but 1/2 is here. And then I go up. Okay, I know it has to be smaller than 1/2, but bigger than 1/4. So maybe I'll just say 1/3. Okay, we're just estimating here. We're trying to see about what the graph is at 1.5. All right, so let's take a look at this one over here. We're going to be doing the same thing. We want to start by making our charts. Okay, so again, I want to tap into that -1 so I can get a larger start. So if I have 1/4 to the -1 power, I'm going to flip that fraction and I'm going to get 4. Okay, then I'm going to take that fraction and raise it to the 0 power, and then I get 1. Next, I'm going to take that fraction and raise it to the 1 power, and then I just get 1/4. And lastly, I'm going to raise it to the 2nd power, so it's going to get even smaller. Okay, when I distribute that 2 in, I get 1/4 squared, which is the same as 1/16. So I want you to go ahead and try and plot that on your own. Even by the time you get to 2, you're going to be really, really close to that x-axis because you're going to be at 1/116. Okay. All right, so let's take a look at word problems where this is going to be helping us out. Okay, so we're talking about movie sales. And so typically, when you are modeling movie sales, this one is actually going to be a decay equation. You think, you know, when Twilight or whatever movie you really like first comes out, people pay, you know, big bucks. They want to go see it that first weekend. And usually after that first weekend, sales start declining. So this represents in millions what that would look like. So we can actually model how the decrease of sales looks. So really, we're just doing the same thing. We're still setting up that chart. So we're going to use this equation listed right here to go ahead and represent this situation that's happening. So all I'm going to do is I'm going to take this equation and I'm going to plug in my x values. So I don't want to know -1 weekend, so the weekend before it comes out. That doesn't make any sense. This scenario really only makes sense starting at the first weekend to the second weekend and then to the third and fourth. Okay, so 0 is representing that first weekend that it comes out, and we have 49.9 times 0.692, and that's going to be raised to whatever power we choose. So first let's raise it to the 0 power. This is where students get tripped up. I'm only raising this part right here to the 0 power. This 49.9 is not being raised to the 0 power. So that's like saying 49.9 times 1. So I'm going to write it as 49.9 for the first weekend. Then the next weekend, I shouldn't erase that whole thing. I'm having 49.9 times 0.692 raised to the first power. So really that's the same as 49.9 times 0.692. When you do that, you get 35.53. Now we're going to raise it to the second power. So part of the trick in this is learning to use your calculator correctly. So I encourage you guys to get help on that because sometimes it's as simple as you're entering it into your calculator wrong. So why don't you be practicing and making sure you can get what I'm getting. So next you're going to take 49.9 times 0.692 raised to the second power. When you multiply all of that, you get 18.52. And I apologize, this should be 34.53. I wrote that down wrong. Okay, then let's take a look at if we have it raised to the third power. Okay, so now we're taking 49.9 and times 0.692 raised to the third power, and you get 11.28. So this is going to give us a good start. I'm going to go ahead and I'm going to go by fives on this. Okay, so I'm changing my scale, so it's no longer 1, 2, 3, 4, and I'm going to go by 5. So for 0, I'm going 5, 10, 15, 20, 25, 30, 35, 40, 45, 50 is here, so I want to go just below it for my first one. For number 1, I want to go almost up 35, so I'm going to go 5, 10, 15, 20, 25, 30, and here's 35. Now, because our x, we're not changing the scale, this will probably look a little steeper if we were to change the scale of everything. But for the purposes of just learning it right now, that's okay. So for number 2, you're going to go up almost 20, 5, 10, 15, almost 20. And lastly, for number 3, you're going to go up a little over 10. So 5, 10, and just a little above. So we're almost got it down to our graph. So if you wanted to, just to check, you could see what the fourth is equal to, just so you really make sure you have a solid graph. And if you were to do that, you get 6.87. So just above right here. And then you can go ahead and draw it sloping down. So again, we're not going to ever cross the x-axis. Having negative ticket sales doesn't make sense. Okay, so we're not going to cross the x-axis. We're just going to get really, really close to it. It's going to approach the x-axis. So let's take a look at number 6. I'm going to get you guys started on it, and then I want you to graph it and kind of figure out some things along with it yourself. Okay, so it gives you the model of the function right here. So again, it's going to be a decay equation. Sorry, there we go. So it's going to be a decay equation. So I want you to use this equation. So we're talking about modeling car sales. And a lot of times with word problems, I'm not going to sit and read the word problem to you. I suggest you pause the video, take a second, and read through it yourself. So when we're talking about the car sales, the longer you drive a car, the less money it's worth. And that's what this is modeling. So I want you guys on your note sheet to fill out a table. Negative days owning a car doesn't make sense, or weeks, or what's our x representing? Years, I'm sorry. So we want to figure out the value after 5 years. You need to estimate it. So I would suggest doing all the way to 4, having your graph slope down, and then estimate it after 5 years. Okay, just like we did on 3 and 4, where we used our graph to estimate it. Right? So fill in the chart, plug in each of those x values for x, or sorry, it should be t. Okay, we're using t in this equation, but it will still be graphed on the x-axis. So I want you to go ahead and graph that and then estimate it after 5 years. Once you're done, please make sure you take the quiz.